This is episode number 54 of DevOps Paradox with Darren Pope and Victor Farsick. I am Darren.
And I'm Victor.
And today we have more guests. Welcome to our neighborhood.
Thank you.
Thank you.
This neighborhood may be a little, how shall we say today, chaotic? Victor, do you want to go ahead and explain the backstory to why our guests are here today?
Yes. So I was working here on and off in different experiments and ways of using Chaos in the past. And then I wanted to refresh my toolset, let's say, not long ago. And one of the reasons for that need to refresh is because Darin and I decided to write a book about chaos engineering in Kubernetes and do some course in Udemy. And then when I explored what's over there right now, I stumbled upon something called Chaos Toolkit. We used it together with a few others, decided that's the one we like the most, created a course, wrote the book, blah, 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 all that stuff, right? And so I thought, hey, it would be cool instead of me or Darin talking about chaos engineering in one of the episodes, why not invite the guys that made it? I mean, not made chaos, but made Chaos Toolkit. And that turned out to be, and I will probably butcher your name, Sylvain? Does that sound right?
Yes, it sounds good. Sylvain,
Okay.
in it.
And
No
Russ. Russ
Is easier, I think, slightly.
So I'll let you introduce yourself, guys.
Okay, well, I feel for a podcast like this, I think the tech expert should do the introductions. And he's looking at me with such glee at that thought. So I'm going to hand over to you, Sylvain, to do the first honors, and then I'll just come in and correct you later.
Well, I appreciate that. Thank you so much. Well, as you can tell, Russ is not my friend. Yeah, we've known each other for a long time, and I think Chaos Toolkit came out a bit out of so much of our discussions over the years, probably more on the design part of software in the past, until I guess 3 or 4 years ago, something like that, where we saw the other side, the ops side of that, and that's where we ended up discussing about chaos in general and Chaos Toolkit as our answer to that. So my name is Sylvain, indeed. So I'll say my full name for once, but I'll keep to my first name otherwise. Sylvain Hellegouarch. Believe it or not, even in France, I struggle with it. So that's fine if you call me Sylvain. So I've been in software development for a very long time. I've started, and I'm still at core a software developer. That's where I really love being. But I've had the luck to actually and the opportunity to work in various aspects, which led me to conclude that really to become a good software developer, you really need to have a systemic view of your system. And once you have a systemic view of your system, you realize it's all a castle of cards, and you really need to test for how the castle reacts to a variety of signals. And that's why we ended up with chaos engineering in general, and being really having a lot of fun recently about that, leading to reliability, as probably we'll discuss later on. So it's been a long journey coming to that conclusion, but it's actually be a very fun journey. I'm sure we'll speak more about the tech itself later on, so I won't dive into that right now. Russ, on to you.
Thank you. So now I get an opportunity to correct Sylvain, but you can't really correct him on his own perspective on himself. So I think the only thing I can add to that is, as I explained to most people that introduced to us for the first time, is that it's a minor miracle. He's French, I'm English, and we get on so well. We ignore many hundreds of years of problems to ensure that we're best friends, and we'll be best friends for as long as we have. And my background is that I've written and contributed to 6 or 7 books in software development, delivery, and different operational models. And chaos engineering has been a big part of that, with learning chaos engineering out last year, chaos engineering out in the last month, both from O'Reilly. So it's been an interesting journey on that side of things, but that's more like the documented stuff. The interesting stuff is the practice of what we've done and what we're doing together as a team. And so our journey has been going on now for probably 4 years, 5 years, and it's now really taking things to the next level by focusing on what people are actually doing and what they want out of doing these things. So the tech is really fun, they're really, really awesome. But the piece that always gets me the most excited is what people are actually learning from doing any of these things, beyond the testing approach, but into the what are they doing to learn things is where my head's always at. And it's a pleasure to be here.
So I really want to ask, what did they learn? But before that, very, very quickly, just in case somebody doesn't know what it is, what's chaos?
Ooh.
What's chaos engineering?
Okay, I can tell you what it is, and then I'll briefly address what it's not. Chaos engineering is, first and foremost for me anyway, it's a mindset. It's a way of looking at a system and asking questions about it. And some of those questions are related to its robustness. So robustness is often misunderstood, in my opinion. People invest in robustness. Robustness is for the stuff you know might happen. So when you look at a system, you go, okay, we probably need an HA database. We probably need a backup strategy for that database. We probably need more than one instance available, so that if one goes down, then we still have one left. And we maybe need to start to use circuit breakers, bulkheads, all these wonderful patterns that are out there that we try to introduce to systems to make them more robust. And you have to extend that out, of course, to the people involved. It's even more important when you consider the people and how they react. Where do they go? What do they say to one another? What are they feeling as they go through a challenging circumstance? So chaos engineering for me is looking at that complicated environment. And firstly, you can do chaos testing and experimentation, where you are looking to prove and improve your robustness. So, for example, you may have invested a huge amount of money in observability, but have you ever explored what happens with observability when a problem occurs? What are people looking for? And so that sort of practice gives you the ability to, in one circumstance, make sure that that particular part of your system is going to contribute a net benefit to things, rather than become a source of obfuscation, maybe. So there's that. And that's all about robustness. But the really interesting edge for me, the piece that's often forgotten, is that there's the desire to be more resilient when we're meeting challenging outcomes, challenging situations. So what that resilience means, very, very loosely, very, very high level, is that you are better prepared for when things surprise you. Okay, when surprising circumstances happen, the phrase that's often used is you're poised to adapt to it. You've invested in your ability to have that poise. You've invested in your capacity to have that poise. Chaos engineering has a huge part to play there. It's one tool in the toolbox, really. And what it does is give you the opportunity to play out scenarios and practice what happens when something surprising occurs. So this is different from proving what you knew was going to happen. This is trying to practice how you react and learn from when something surprising happens. And that's where the real value is. That's where the lessons to be learned really are, is when you start to look at, okay, what really does happen when something's going wrong and maybe we don't know about it at first? When do we first know about it? When do we then start to get to a resolution on what it might be? Who has to be involved? How do we synchronize? How do we respond? those resilience capabilities, if you like, are one of the things that you can also practice and develop doing chaos engineering experiments.
What is it not? You never got to the not. I was waiting for the not.
Yeah, no, sorry. I felt like I'd gone so monologue on it. I decided to stop. Okay, so what is it not? The answer to that sounds a little bit trite, but it's more about trying to address what people mistake it for. It's not just breaking random virtual machines, for example. When you look at things like the Chaos Monkey, is a great example of this. It's a fabulous tool. Did a great job of causing a bit of a stir, shall we say, and getting people thinking a little bit this way. But I think a lot of the work since then has been trying to tell people, no, it isn't just that. It isn't just about breaking. Breaking things tends to be the easiest thing to achieve. Let's be honest. It's pretty simple. Just take, in my case, take my daughter into work and give her a keyboard and let's see what happens. That isn't the point. At least I hope it's not, though she may have fun on the way. What the point is firmly on the side of, well, what are we going to learn from all this? Have we set ourselves up to learn? Breaking things is fine. Stressing, performance exploration, security exploration. The answers you're looking for that you may not have right now, and this is the answers you get from chaos engineering that you don't get from that you haven't had in the past, is you begin to answer the questions, how will everything come together when things are difficult? There's a great analogy for this very, very quickly that I like to use, which is that when you put a system together and you design it and you put your continuous delivery in and you've got your DevOps, silos broken down and everything looks like it's delivering quickly and qualitatively into production. You're really happy with that, and you should be. That's been the major challenge for the last 20 years, so let's celebrate that. The difficulty is what you've done there is you've built a really good set of players. You bought some good players, but you haven't yet tested those players under match conditions. So you can have fabulous observabilities, fabulous other strategies in there, robustness strategies, but until you bring it all together and put it under significant strain, not just performance and traffic, but the strain of inevitable failures, that's where you start to learn how it all really plays well together. So resilience engineering, chaos engineering, continuous verification, these are all approaches and tools to try to help you explore what will happen when something occurs, whether it's known or unknown. So yeah, very, very, very long answer to what it's not is the things like just breaking bits or just, I had a great phrase from a bank that called us and said, you're going to love us. We do chaos engineering. In fact, we're done with it. We've done it. It's perfect. It's done. And I thought that's an incredibly interesting perspective. When is it ever done? Are you telling me the system's turned off now? Because that's okay. I get that. That would be done. But if it's a live system and it's being used and it's evolving, then you're never going to stop learning how to look after it, how everything plays well together, how, it's a practicing reliability, as we call it. Practicing reliability goes alongside your speed of feature and utility delivery. It's a part of your game. And so you couldn't argue it's ever done until the system's turned off.
What would be then, let's say, prerequisites? So let's say that I know nothing about it, about chaos. I want to start practicing. Can I just do it, or do I need to be on a certain level of maturity of certain things?
So I'll have a crack at this and I'll let Sylvain do some talking. Otherwise, he's going to fall asleep, and it's not fair on me. So very, very, very quickly, it's a great question, and I've addressed it in an article that I published yesterday. And I can get you the link, and maybe it can be distributed with the podcast, etc. The short answer is that while it would be helpful if you had things like good observability in order to do chaos engineering well, it's less of a maturity model, more of a mutually beneficial relationship. So as you think like a chaos engineer and you start to look at systems through this lens of how will it react when things go wrong, and you can start to practice these things straight away. You wouldn't necessarily practice them immediately in production. Let me just put that out there. If your experiment is very likely to destroy the system, don't do it. Maybe pick something a lot smaller, a lot more contained, and start to learn from that first. But in terms of technical prerequisites, I don't think there are any obvious ones. And it's an interesting perspective. So I heard this one. I'll just give you this quickly. Someone said to me, do I need high quality observability? Does reliability work require high quality observability? The answer to that question is, how do you know it's high quality observability? How do you know? What is the measure of high quality observability? For me, one of the big parts of that measurement is, how does it work when something goes wrong? How does it play into those scenarios, those moments when it's most needed? If you don't practice what we talk about, reliability, chaos engineering, system verification, game days, if you don't practice some of these things, you don't know how it's going to play in those circumstances. So my take is, you don't know it's high quality yet. What you do know is that you spent a lot of money on it, probably. You've bought the right thing. You've followed all of the great advice to get it working well. You've got a great player. But the thing that matters is, have you got a great team? And so practicing reliability, you can do the moment you think about doing observability, because it helps you fashion the right observability for you so that you have a great team at the end of it. It's all very well having great players, but if the whole point is, it's not about a single player. Sorry, Sylvain, I may have gone for that one. Okay, I'm getting thumbs up.
In a way, I think it boils down to what you said before, along the lines of, it's about finding out things you don't know rather than things you do, right? And now, my kind of dilemma, let's say, is, you can initially contain it and say, okay, I'm going to practice this only on a single application, right? And I don't have observability and all those things, but it's okay. I'm going to do it on a single application. I'm going to shut down an instance and see what happens. And you know what? I already know what's going to happen. That's such a simple case that I know what's going to happen. I don't believe I would need an experiment for that, right? Now, what I don't know is, if I do the same thing in a system as a whole, I might actually find out that some 7 levels beyond what I'm actually touched, something got broken. Right? Kind of, you shut down, I don't know, replica of an application, do something with networking of application A, and it turns out that application F is misbehaving, right? Those are the things you don't really know. But my dilemma is then, but how do you find out if you are not able to observe the system? I'm not going to repeat the word high quality, but to observe the system one way or another.
So you're absolutely right. I guess what I'm saying is that most companies, technical groups, think they're trying to do everything right. Or if they're not doing everything right, there are other reasons why they're not doing it right, and people are hiding costs or something. I don't know. But generally speaking, people are trying to be as prepared as possible. What chaos engineering is good at is telling you where your assumptions fail. And so in going back to your point about observability, you should invest in observability. Absolutely. And just by thinking about a system in terms of what will we do when the time comes, will get you towards observability. I think it's not like, what I have a problem with is when the phrase is used, you must do this first before. I see it as going very much in tandem. I'm doing it because I'm thinking about reliability, because I'm thinking about how the system responds in failures. You should invest in robustness of the system and observability and other bits and pieces. What we're saying, though, with these reliability practices like chaos engineering is that you can do everything as right as you think you will, but you don't know it. You don't know. And know only happens, it can happen in one of two places, right? So it can happen when the house is on fire, which is not the best time to learn. We've all had that moment where, you're in a personal crisis and one of your friends turns around and says, if you'd only done this differently in the past, you wouldn't be here now. And they're right, but that's not the moment to learn. Okay, so what we do is proactively explore the system. When you think you've got things as right as you want to, or think they can be, perhaps, then these practices tell you where your assumptions are falling down. And they also tell you where you might want to improve, okay, where you might want to learn from further exploration. They give you sometimes the evidence of your own, of the lack of the mapping between assumptions and reality.
I think, if I may, what you said earlier, we are heavily based on hindsight, where, like Russ just said, you're going to say, if you had done that, if you had, achieved this or that. Right now with COVID, you see that right now we have a saying, I don't know in other countries, but in France we say we have 65 million coach for the French football team, where basically everyone knows better than the guy who's doing it or the person doing it. Sorry. So what I'm saying is, with COVID, we see that again. They should have done this. And, I'm no better than anyone. Sometimes I feel like that. But at the same time, 2 months ago, there were signs of COVID, but not to what we have now, right? So chaos engineering is not here to fix something you know about. It may help you to unearth, facets of that, but it's to prep you to behave, right? Again, if you have great players, if they've never played together, and you see that sometimes in some teams where individually they are all in the best, clubs around Europe or elsewhere, but when they're in national teams, suddenly the team is not that as good as the individuals that are part of it, because they are not used to practice together. And the whole point of chaos engineering is not to say, hey, I've done that and I fixed it. It's, first of all, your system the next day is different from yesterday. Because of that, already your assumptions from yesterday are likely not necessarily wrong, but they have an offset. And have you tried that offset? So the idea is not to continuously chase, but I think it's the idea that if you practice, you'll feel less stressed. You'll have a better understanding of how to react. Last year at ChaosIQ, we had a TLS issue. And that's a shame, because in chaos engineering talks I've given, I've always used that bloody example, and yet we fell into it, right? So there is that. But it was the third day of my holiday, and I wasn't there. And the folks, actually, the team called me and said, well, we've tried many things, but we can't figure it out. And of course I couldn't, because up to now, so many things had been in my mind, and I haven't been very good at letting other people, not even document, because usually documentation goes so far, but practice the issue. And that's really what, at least at ChaosIQ and with Chaos Toolkit, we're all about, is you going to practice. Even the little things can have big repercussion, if I may use a cliche. So the goal is in that practice you do. It's not necessarily in the one-off tests you're going to run. And that's what we're passionate about. Making teams better through that.
Yeah, absolutely. I mean, just one other story that is worth, I think, just pointing out is the fidelity of the information that you get out of practicing the way that Sylvain's talking about. Because I've had that conversation, and I won't mention the company, but they're a big company, massive, global, very successful organization. entirely based upon their internet services. And I spoke to an engineer there, a fabulous engineer. He came up to me after one of the talks on chaos engineering, and he said, look, if I know the system's going to fail, I don't need to do the experiment. I know. And I said, okay, you may be right. I like your confidence, sir. However, that word no is a bit awkward because there are levels of no. And what we normally say when we use the word no in English is we mean we strongly believe. We really strongly believe. We have no evidence because it's never happened, but we strongly believe it. And I said, it's okay to be, to have strong beliefs in how your system will respond to things you know about, that you've got great observability, etc. You've got all these things there, right? You know they're good. But what you're really saying is you strongly believe. And one of the things that you can get out of practicing chaos engineering and system verification, for example, is you're going from strongly believing, into knowledge of a given moment in time, knowledge within a given context and a given set of circumstances. It's not generally applicable knowledge to everything that ever might happen. If you can get a really good MTTR over the course of several weeks, that's a good measure, but that doesn't mean the next instant that's going to be your time to recover. Okay, so you practice these things because one of the things you will get is a greater feeling of knowing more about how the whole system works together when, in these difficult circumstances. And in that particular case, this gentleman who said, I know what will happen. And I said, you know what will happen to the database, but what happens to the rest of the system? He said, I think it will fail. And then one of his friends, she came over and said, I'm not sure it would. And so you can see the doubts building, all right? And it's good. A doubt is a good thing. Chaos engineering is it's based on a scientific mindset and a scientific approach. And so skepticism is a good thing. So we encourage skepticism. You practice because of skepticism. You practice because you know you don't know. Or at least, you realize it's a strong belief.
I think that you both now mentioned two of the huge issues that normally companies have and that are not really directly related with chaos, right? That ability to say I know is just horrifyingly dangerous. And and it's not really related in my head to chaos. You can say the same thing like I wrote those 50 lines of code, I know they work. I don't have to write tests because this is simple code. I'm going to write tests when I'm unsure about it. It's just that same mindset of translating using word no for instead of a guess maybe or something like that, right?
Yeah. You can think of it like TDD for the system under really interesting circumstances. One of the things that we get back as a comment back from our customers actually is that chaos engineering is really good at helping them prove and improve their robustness, which means they're learning from their assumptions. They've made good assumptions. They've made good investments. They've tried their best. And it helps them prove and improve on those guesses, those beliefs, really. But the big challenge is, of course, the resilience, which is the preparedness for when these circumstances occur. How good are you anticipating synchronizing and responding to something? How good are you? You don't know until you practice. And so that area is one of the tools in our toolbox for that is around game days, which I think is a phenomenal exercise. It can be expensive in people's time, but it is singularly the most powerful tool I know of at the moment to proactively try and learn from how the system will play out. And your chaos engineering experiments, the automated ones, can be part of that. They are often the backdrop to it. But in the middle of that game day, you're going to be learning so much, you're observing so much. And the key question actually in all of that is what happened? What is going on in people's minds, in the dashboards they look at, in the observability tooling that's provided, in the system elasticity that you can take advantage of. What happened? And that's why the core concept in our recent tooling is the timeline, the ability to take many, many, many sources of information and bring it together to help you answer and explore that question of what happened, in what order, to try and beat what Sylvain alluded to earlier, which is one of the big problems with postmortems or incident analysis, as I prefer, is that hindsight bias is a big issue. And so one of the things we try to do with the timeline is support analysis of what happened in the order it actually happened. Very, very quickly, there's a real problem with analysis in that people tend to look at things from the back end to the front end. They go, well, that should have happened. Oh, they didn't do that. I mean, we see it now with COVID all the time. Why didn't we, isolate 2 weeks earlier than we did? Well, at the time, we had imperfect information and it was a complex picture. And a judgment had to be made, and it was always going to be suboptimal, probably suboptimal. So they did the best they could do. Some countries have got it extremely better than others, right? That's okay. That's what happens in those circumstances. It's a complex problem, so the answer isn't going to be do that. Judgment has to be involved, and judgment with imperfect knowledge. Anyway, so that's the same thing we see when people are trying to understand analysis of a system that's had a problem, such as your online system, your internet services, unpacking what happened in the order that it happened, coming from the front end to the back end, going from the front, going earlier than the beginning. So you're looking at the system way earlier than that. You can start to understand the many facets that contribute to the complex situation that emerged. And that's the interesting thing that's the thing we're most interested in now. Chaos engineering gives us a way of deliberately orchestrating these opportunities to explore what happened and learn from them.
To me, it's also very interesting what Sylvain said before about, what was it? Example with TLS, right? And I feel that is happening also very often. No offense, Sylvain, but kind of that a person or a group of people would be doing stuff, and that includes chaos engineering, but equally applicable to something else. They learn something from it, great, but the effect of that learning is extremely limited, right? Kind of like, yes, I learned and that can help me in my job, but the rest of my company still has no idea how to fix problems with TLS certificates. I'm not attacking now, but kind of, using just an example, right? And that might be probably more important is actually how you propagate that learning experience and the discovery, maybe than actually the experiment itself.
Yeah, exactly. The learning is the key thing here. And you don't realize, but the more you do something, the more automatism you create. We often speak about automation, but we see it as a tooling prospect. The more you practice on something, the more your brain let go, and the more you respond faster. So we've got that with Russ sometime where someone is going to say, like he explained earlier, well, I've done that once, I fixed it and that works. First of all, it's great you did it once, because at least you're one step, on the ladder, and I think it's fantastic. But the problem is, even if you found and fixed something, the learning doesn't happen once. I've got a baby daughter who's 4 months, and soon she'll have to diversify her food, right? And what I've read is that you need to try certain food like up to 7 times so that their taste get used to it. The first time you give that food to the baby, usually they'll just reject it, likely, unless it's like raw sugar, probably. But otherwise, they'll just, I don't want that. So you need to train. And as at some point, their body is going to react more appropriately, automatically, and the brain will let go. And I think that's what you don't realize is when you practice, you're actually learning. The learning is not necessarily in a concrete artifact at the end of the day. You may never fix the issue you found, but you're better at recognizing it. You're better at looking for it. You're better at handling it in general. And that's invaluable for any company. If your team is getting better at it, it's just, you've gained so much. So the point we made when I came back from holiday and we had fixed that TLS issue was not to say, obviously we didn't want that TLS issue to come back again. That's where you come back with monitoring, proper alerting, and all the shebang. That's obviously the thing. But what you really want to do is, how do we practice to, panic less, be better as a group of people? It's really people-centric, to be honest, that thing. And that's where we are at, right? It's all about the learning arrives by practicing, right? And you don't necessarily know it. It just happens, right? But you have to do it. It's unless you have extremely a raw talent for that thing, it's not going to happen, on its own. So you want to practice.
There's actually just to call out a friend of ours. Certainly someone we admire greatly is John Allspore's recent work on that. He's done some amazing talks around how you learn from these sorts of activities. And a big deal in that is the concept of the story. So whatever you come out of having invested in doing a game day or some chaos experimentation, the outcome of it is a story that can be told, a compelling story, something that everyone could be interested in learning from. And this is something that's lost when you distill these situations down to just like the bullet points. Here's our post-mortem analysis, and it's got 5 bullets. And actually what it says is we should never let Sylvain go on holiday again because he's the TLS expert and that's okay. The story is more interesting. I remember being in that incident, and I can remember talking to Sylvain over dubious text messaging mechanisms because he was going through black spots, and Lord's knows, I don't know where he was in France, but it wasn't an easy place to come back and fix anything. And so it was a hugely challenging time, and all of that is better captured if you have a story to tell. It is a story that doesn't. I'm not using the word story in the fictional sense. I'm telling the actual narrative of it is the most compelling part. I mean, a good analogy for this is if you've ever, many people have watched the recent Chernobyl TV program. And the beauty of that program is it tells it from front to back. So you go through it with them. And you do get this sense of, oh my goodness, they really did think they were doing the right thing then. And they thought they were doing the right thing then. And they thought they were doing the right thing then. That's the right way to tell the story, to learn from it. The wrong way to tell the story is like I did just to begin with. I said, TLS problem, Sylvain, I can't go on holiday. Here's some answers. We're done, right? That's not what the outcome of a good incident analysis is. It might be some findings, might be some suggestions, but the more important thing is the story. And that's what our tooling is trying to help you with.
The tooling is Chaos Toolkit.
That's one part of the tooling, yeah. That's for the chaos engineering part. The reliability toolkit is the piece that we've added around that to do things like game days and verification, which is achievable using Chaos Toolkit. The remit of Chaos Toolkit, when we first came up with the project, was to enable the individual to do some chaos engineering. And so it's got all of the pieces in there to do that without a doubt, including how you then report on what happened and try and build that narrative. But it's pretty limited in what it does. It doesn't easily, or that can be used to support the larger picture of how everyone learns from it. That's not what it does. That's not what its purpose was originally. And so what we've done is we've built the reliability toolkit, which is our SaaS, that gives you that place to practice these larger gamut of activities. That's what it's there for.
So Chaos Toolkit, open source.
Yes.
Reliability Toolkit, pay us money.
Yeah, very simply. That sounds about right. Yeah, but don't pay us too much. We're not asking for a mortgage.
There's a lot of financial jokes I could throw in there. I'm not going to. Well, cool. This was a great talk. Where have you seen people, let's say big organizations, because I'm assuming you've got some big organizations that you can't say their names, which is fine. It seems like the biggest disconnect is people think they know, and you start asking around, and then they use the word no, and once you start probing more, that no becomes think. What was that biggest realization for one of your clients? When did the light bulb go off for one of those clients?
Oh, I've got a couple of great stories in there. I'm quite fortunate in that I've been training people in chaos engineering now for a couple of years, so you get to hear some great confessions over end of day beers. I think one of my favorite stories is of the gentleman that came in on the first day of one of the courses, and he said, "I like everything you said, Russ, but our system doesn't fail." And I thought, okay, that's great. That's, well done. He said, yeah, it's a single VM. It's a very simple monolith. There's only a few of us working on it, and it's been running for 3 years. It's never failed. And I thought, fair enough. Okay. And I said, maybe there's a complexity argument in this. Maybe, the more complex the system is, the more chance for failure, etc. Those are provable number crunching kind of things. You can go there. The beauty of it was I'm a big believer in Murphy's Law. Because the next day he came in and the first thing he said is, "Russ, did you break it?" I was like, no, I haven't touched a thing. I couldn't, I don't think. I'm not a hacker, I'm not going to do anything that's like that. And his one VM had failed overnight. Worse than that, it got into interesting corruption issues, and he had a disaster recovery strategy that had never been tried. The database had been backed up and never restored. Again, with hindsight, you look at these things and go, duh. But then everyone does that, and no one wants to explore the what ifs like this. It feels like overkill until it's not. And so we see that over and over again. We get it with some of our bigger customers who've had whole scale problems of things that have hit the press. That in the early days, I used to joke that I feel like I'm a bit like an ambulance chaser. I'm watching systems fail, and I'm waiting for a phone call. And it doesn't happen immediately, because right in the moment when you're learning and you're trying to patch things back together and you're trying to mitigate things, that's not when I get called. Not when we get called. We get called when people go, okay, that can't happen again. Or if it does happen again, we need to be better at this. And so that's always the moment when people find us interesting. Other big stories, I know of at least one large company that were very skeptical of chaos engineering, understandably. I mean, pretty much if you'd said to them you want to do chaos engineering, their instinctive reaction was, no, we've had chaos before, we never want it again. Why would we buy this thing? But one of their people was, I guess, open-minded enough and friendly enough to go, let's give this a shot. Let's see what happens. And so they started doing their first chaos engineering experiments at 9 a.m. And by midday, they'd found and proven several very large weaknesses in their system, and not caused those weaknesses to catastrophically fail. They'd found enough evidence of them to go, actually, this is for real. And that was enough for them to then go, you know what? We're not as prepared as we thought we were, even from a robustness perspective. And so that was always great to hear. I mean, it's a quote I beg them that we can say, but they won't let us quote it on their behalf. But they said, tell people it happened, absolutely, because it's a great story, and it did happen. It was a crazy conversation in Slack. But that was a massive company that found several weaknesses in a few hours. I'm not saying everyone can do that. I'm not saying that's necessarily the goal. What is interesting is that you only have to do a few small things, practice a few small things, and it will make you far better than you were without them.
What is the biggest objection to doing chaos engineering within a company? Give me the top three.
So the first objection, the top one, is this is gonna cost us money, right? This is going to threaten our production system. This is going to mean my developers are not shipping more features. It's the same argument and rationale that people use against putting in place testing. I don't have time to write tests. I've got to ship features. It's the same naivety, I think, of, well, you've shipped nothing until you've proven it does it. How would you prove it without tests? Oh, you're going to have people do that? That's expensive, isn't it? So there's, the old argument of you will go faster if you have tests. And it's been proven now in works like Accelerate by Nicole and Jez, in that it talks about continuous delivery will speed you up. Testing will speed you up. Doing these things makes you quicker, makes you consistently quicker. Well, it's the same thing when it comes to running your systems and needing them to be reliable. Very few companies say we don't need to be reliable. But then you say, okay, well, what are you doing about reliability? And they'll tell you all of the technical things they've bought. And you say, right, so you don't have outages now? Yes, we do. Okay, of course we do. What are you doing about those? We're trying not to have them. And then you say, okay, well, that's a good thing, but maybe we could be good at them when they happen, because we have to look back historically and say they do happen. So that's actually number 2, is people often say it never breaks. It won't break. We've done everything right. It won't break. And in those circumstances, you sort of sit there and go, okay, but it has broken, right? It has. Almost everyone has relatively recent stories of when things didn't go right. And sometimes they're related to delivery. Sometimes they're related to execution. What we're saying is, if you just do a little bit of this work on top, if you balance a little bit of your velocity work as you see it against the reliability work, then you will be doing this better and faster in the medium and longer run. I guess complaint I see anyway, number 3, is that I used to get this a lot, is I don't want chaos. I don't want to engineer chaos. And so there's a definite complaint against the phrase. And I've spoken at length of this with other great people in the industry, and a lot of people are frustrated that it's misunderstood this way, and some people never ever hear someone complain like this. But I spoke to a lot of banks, and they'll tell you they don't want chaos. No. We've had that. That was 2008. Do not want that again. Right now, they're probably saying we don't want 2020 again. So, when you talk to organizations like that who say we don't want to engineer chaos, why would we do this insane thing? You do have to reframe it to, well, do you want to practice reliability? Do you want to be improve how you're prepared for issues? Do you want to do that instead? Do you want to, it's not insurance, it's practice. Do you want to do that? I used to use a phrase, I haven't used it for a long time now, but the phrase, do you want to do continuous limited scope disaster recovery? Which is chaos engineering, but I just don't use the phrase. Those are the top 3 I've seen anyway.
Well, it could be worse. It could be like serverless. You cannot be more misunderstood than serverless, right?
Don't get me started. If there's one thing we could stop doing in this industry is naming things. We're no good at it. We're terrible at naming things. I mean, NoSQL. We named a beautiful renaissance in data persistence and access technologies, and we name them by what they're not some of the time. I mean, that's just that immediately should have got us barred from the naming groups immediately, right? Microservices, don't get me started on that one. I train people in microservice-based development, but I don't really call it that. I say to them, look, we're going to do microservices, but first, day 1, question 1, what is a microservice? You tell me, because it doesn't matter. Well, we get there quite quickly. What matters is what can you do with your system that you couldn't do before. So yeah, I really do think we should stop naming things.
And stop is probably a good word to use right now because we've gone on for a little bit, and I think everybody's got meetings in 10 minutes. Thanks for hanging out today, guys. It feels like we're just getting started at roughly 50 minutes in. We'll have to continue this. Maybe you can come on the live stream on one of the days and live on the edge and show what true chaos is.
Sounds good to me.
All right. If you're listening via Apple Podcasts, please subscribe and leave a rating and review. All of our contact information, including Twitter and LinkedIn, can be found at devopsparadox.com/contact. And if you'd like to be notified by email when a new episode is released, you can sign up at devopsparadox.com. The sign-up form is at the top of every page. There are links to the Slack workspace, the Voxer account, and how to leave a review in the description of this episode. We also have the link to that post you made yesterday, article, whatever you want to call it. What was it? Was it an article or a post? Talk about naming problems. And then we'll have both your contact information. I've got your emails right now, but if you want other things, go and send those over as well. If you want to learn more about what's available, if you want to test out, again, if you want to go take the course that Victor and I did or get the book, go to, let's set it to DevOps Toolkit series. That's the best place because then it's got all the links for all the things. We'll make sure there's a link down. In fact, there's always a link for that because, hey, we're always selling. And we'll also have a link to chaostoolkit.org, which is where Chaos Toolkit is as an open source project. And then also a link over to the company, ChaosIQ. Is that the company name? I'm looking at the domain, but I'm assuming that's...
Yep, that's correct.
Okay.
That's the company.
So it's chaosiq.io. You're a cool kid because you have .io, not .com. Were you just not willing to pay the money that probably somebody had for the .com?
I don't think that's entirely wrong. No.
Okay, well, that's fine. I mean, that's what it is, you know.
We wanted to spend money on the product.
That would be another episode. Let's just call it that way. Again, let's see. Russ, you've talked a lot. I love you, even in this short time. But let's let Sylvain close it out for you guys.
Well,
so sorry, man. I just sort of like threw you to the wolves right now. But
yeah, exactly. The only thing I can probably say is just keep safe.
Keep safe.
Yeah,
that's a good idea. Now, by the time you're listening to this, it's going to be May 6th. That's the release date for this episode. Hopefully, things are starting to ease. In fact, we're recording this on April 24th, and I just saw that Spain. Victor, you probably haven't seen this yet, or you may have. Spain is going to start releasing the restrictions for letting children do things. Now, help me understand. Talk about chaos. Okay, the restrictions have been lifted on the children, but not the adults.
So let me clarify.
That sounds like Lord of the Flies, right? I mean, it's...
Yes, so let me clarify. Yes, children will be able to go out, but they will be accompanied by adults.
Oh, okay.
Remind me of that Stephen King novel, I think Children of the Corn or something like that.
Children of the Corn, yeah, Lord of the Flies, all that. There's nothing that can go right with that. So anyway, that's it for today. Check out all the links below in the episode. Be on a watch because we'll try to get these guys back on a live stream. Maybe we can see a live demo of the pay me things, right? I'm sure you guys would be happy to give me money, right? I do want to call out. I want to call out a couple of phrases that I heard today. So this is sort of like the tags, if nothing else, right? I heard continuous verification or resilience engineering. Those two sort of go together. Lets me know everything known and unknown. That's always a good consulting phrase. I have a much longer joke. And then the other one was sort of the very beginning that Sylvain said, and this is how we'll end it today. Not a house of cards, a castle of cards. If you believe your systems can't fail, think about that last story that Russ just told. One VM, up for 3 years, no problem. Comes back in the next day. What did you do?
I still don't believe that he was not involved somehow. He would never admit it in public. No, I don't believe it.
Thanks again for listening to episode number 54 of DevOps Paradox.